What if I tell you that all of math can be visualized at just one spot? What if I tell you that I of complex numbers actually denotes rotation by 90 degrees? I square denotes rotation by 180 degrees. I raised to 3 or I cube denotes a rotation by 270 degrees, and I raised to 4 would be a rotation by 360 degrees. So not just I raised to 4, I raised to 8, I raised to 12, I raised to 16, I raised to any multiple of 4 will be multiples of rotations of 360 degrees, so they will all be equal to 1. What if I tell you that sine theta in trigonometry had a reason to exist? Sine theta is a measure of how much perpendicular two forces are when they act upon each other. You see this He-Man kind of a person in this image? When he throws the ball onto a wall at 90 degrees, the full impact happens onto the wall. So sine 90 is 1 upon 1. It is loosely written as 1 when we write it, but it is actually a ratio 1 upon 1. This ratio 1 upon 1 denotes full upon full, just as 1 upon 2 denotes half of full, 1 upon 3 denotes 1/3 of full, 1 upon 1 denotes full upon full. So sine 90 equals to 1 because maximum force transfer happens at 90 degrees from the ball onto the wall. If the same person throws the ball onto a wall at 30 degrees, now only half of the impact takes place. So sine 30 equals to half because now only a fraction of that force gets transferred onto the wall. This fraction is half at 30 degrees. Hence sine 30 is 1 by 2. What if I tell you that cos, as you can see in the image at the right topmost corner of the screen, cos is a measure of how much aligned two forces are, aligned two influences are. When the sphere is kept parallel to the surface of the ground, maximum shadow falls upon to the ground. Whenever two forces are aligned and when they produce maximum impact, cos comes into the picture. That is why cos 0 equals to 1, because 0 degree is the angle when two forces are parallel, are acting parallel, or are completely in alignment with each other. Now at the same time, if the sphere is moved at an angle of 60 degree with respect to the surface of the table, what happens is that the influence, the length of the shadow gets reduced to half. At 90 degrees, now the sphere and the surface of the table are completely out of alignment. They are at 90 degrees with each other. So the impact, the shadow that is subtended, that is formed by the sphere, is now the minimum. So whenever two forces are such that they produce maximum impact when they are parallel and minimum impact when they are acting at 90 degrees, cos theta comes into the picture. What if this resource also tells you that complex conjugates are nothing but vertically opposite mirror images of each other? So 3 plus 4i denotes a certain angle which is made, which can be calculated by taking tan inverse of 4 divided by 3. And 3 minus 4i just means a vertically opposite mirror image. That's it. What if this resource also told you that the transpose of a matrix is the entire matrix rotated by an angle of 180 degrees? When this rotation takes place, there should be an axis of rotation. This axis of rotation is the diagonal of the matrix. As you see here, the diagonal of the matrix is the angle by which it rotates, is the axle around which the entire matrix rotates. So transpose of a matrix is the entire matrix rotated by 180 degrees about the axle, and the transpose of the matrix will be the entire matrix rotated by an angle of 360 degrees around the diagonal. All the contents of this book, all the contents of this video are an excerpt from an e-book which is available, the link of which is available in the description. But more about this book later. So now let us come to sine theta. Sine theta is a measure of how much perpendicular two objects or influences are. Now let's just go to this image here. The more the angle at which snow is falling, the lesser will be the amount of snow accumulated. The more the angle with respect to gravity, that is at 90 degree. In this case, in the second case, the angle at which the roof is standing is a 90 degree perpendicular angle with respect to gravity. Gravity acts in this direction, in the downward direction, and the surface of the roof is perpendicular. So the largest amount of snow will be accumulated on this roof. The lowest amount of snow will be accumulated on this roof, because in this roof, in the first image at the leftmost corner, if you can't see the arrow, the lowest amount of snow will be accumulated in this image, where the roof is at an angle lesser than 90 degrees with respect to gravity. The snow just slides. Once again, these images the image of the He-Man like figure was explained before. Now let's look at this image, in which there is a spear-like object. When it is kept perpendicular to the surface of the table, it subtends maximum shadow onto the screen. At 30 degrees, the length of the shadow reduces to half. At 0 degrees, there is almost no shadow subtended onto the screen. So sine theta comes into math when two forces are such that they produce max impact when they are acting perpendicular to each other. You might have come across this formula that sine theta equals to opposite side divided by hypotenuse. But why is this formula? So let's look at this image. Sine theta gives you the perpendicular component of the object, force, etc. The shadow of the stick is max when held perpendicular to the ground. Just look at the shadow of this spear-like object here. So this shadow represents the perpendicular component of the spear. So the more perpendicular the spear is with respect to the surface of the ground, the more will be the angle. The more will be the length of the shadow formed by it. And as this angle reduces, the shadow or the perpendicular projection of the perpendicular component of the spear also reduces, and that is why the spear is like the hypotenuse of a triangle. It is analogous to it, and the shadow cast by it is analogous to the opposite side. This is also called as the imaginary part of a thing, the sine component or the perpendicular component. Cos theta comes into math, on the other hand, when two forces are such that they produce maximum impact when acting parallel to each other. You have seen the image of the bulb and the spear in the previous slides. Now let's take the other image. In this case, two people are pushing this drum-like object in the same direction. Their forces are aligned. The angle between them is 0 degree. Their forces are acting parallel to each other. So now the maximum push is generated onto the drum. But now in the second image, in which these same workers are pushing the drum, they are at an angle of 60 degrees with respect to each other. So now the force gets spread out. It gets reduced. I don't know if spread out is the word. So the forces are less aligned, and hence the push generated is lesser. So once again, cos theta comes into math when two forces are such that they align themselves in the same direction. The angle between them should be very less. The lesser the angle between them, close to 0, the more the push, the more the force. The forces combine into each other, the forces merge. The maximum impact is formed at 0 degrees. But at lesser angles, what happens is the impact gets lowered. Now let's come to vectors. Sine theta as you have seen in the previous slides, is a measure of how much perpendicular two forces are, and it comes into math in all those cases where the net force, the net impact is the greatest when two forces are acting at 90 degrees. So once again we have this image of the He-Man like character who is throwing the ball onto the wall at 90 degrees. This is greater, this is the maximum. So sine 90 is 1 upon 1, full impact takes place. At sine 30 is 1 by 2. So in cross product, the formula itself says net force when two forces are acting cross product is the magnitude of A, that is the magnitude of the first source of force. In this case it is how strong is the force of the ball with which the He-Man is throwing onto the wall. The second source of the force is B. In this case it is the reactive force of the ball. You might have heard of Newton's law, Newton's second law, that to every action there is an equal and opposite reaction. Everything that you hit has a tendency to hit you back, and different surfaces have different reactive forces. The reactive force from the surface of a solid wall will be different from the reactive force from the surface of a sponge. So different surfaces have a different reactive force, and this together determines the net force. The first is how strong is the force of the ball. The second is how strong is the reactive force of the ball. The third is how perpendicular are they with respect to each other. So the net impact depends on how strong is the force of the ball, how strong is the reactive force of the wall, and the third is how perpendicular are they with each other. At 90 degree, maximum transfer takes place, maximum impact takes place. At 30 degree, the impact is reduced to half. Now let's look at dot product. Cos theta, as we noted, comes into those cases in math where two forces are such that they produce maximum impact at 0 degrees with respect to each other, when they are acting parallel, when they are aligned with each other. Now just look at this case. The two workers are pushing at 0 degree, so the force is maximum. In the second case, the two workers are pushing at an angle greater than 0, so maybe 60 degree, and the result is that the forces are less aligned, so the push is lesser. In this case also, the net force is how strong the force of worker 1, this is denoted by magnitude of A. Then we have the magnitude of B, how strong is the force of the second worker, and then we have the angle between each other. If the angle is the minimum, that is if the angle is 0 degree, the force will be maximum. If the angle is at 60 degree, the net impact onto the drum will be the least. So cos theta is a measure of how much aligned these forces are. The more aligned these forces are, and if the impact is maximum when the forces are the most aligned, cos theta comes into the picture. Now we come to the subject which complicated unnecessarily your teenagers: complex numbers. Complex numbers come into math when one influence splits into two or more branches, either due to rotation or for some other reason. So let's take this image. The first image is of the earth rotating around the sun. I means that there is a rotation of 90 degree from where it started off, I raised to 1, that is. I raised to 2 means it's in the opposite corner. I raised to 2 means a rotation of further 90 degrees, so 90 plus 90, 180 degree. I raised to 3 means a further rotation of 90 degrees, so 90 plus 90 plus 90, a total rotation of 270 degree, and I raised to 4 means a rotation of 360 degree, and that is why it is back to square 1. I raised to 0 is 1 because 1 means as it is, kept wherever it is 1 upon 1. In math, a lot of times the number 1 might be a ratio 1 upon 1, not the absolute value of 1, like 1 kilograms of tomatoes or 1 kilograms of onions or 1 liter of milk. It may be a ratio. In probability, for example, the number 1 means a ratio 1 upon 1. It means full or complete, or kept wherever it is, no manipulation, no stretching, no zooming in, no zooming out, no shrinking, nothing, just kept where it is. Minus 1, which is a rotation by 180 degree, the minus sign indicates that the direction has changed. The magnitude has not changed, the direction has changed. I, only I, that is 1 I upon 1, means that the size has not changed, but surely the size of the earth does not change due to the rotation, but surely what has happened in this case is that it has moved by 90 degrees from the starting point, and minus 3 would mean it has moved by 270 degrees from where it has started in the anti-clockwise direction, or by minus 90 degrees in the clockwise direction. There are two ways to reach to minus 3, minus 1 or I cube. One is to move by 270 degrees in the anti-clockwise direction, or by moving 90 degrees in the other direction, that is the clockwise direction. You might have wondered, why do we require the complex plane, why there is a real plane and the complex plane. The real plane consists of all real numbers. So if you are moving at a speed, so if your car is moving in one direction, we call it plus 5, let's say a velocity of 5, so we call the velocity of the car as plus 5. If your car is moving in the opposite direction, we call the velocity as minus 5. But what if your car is not moving just front or just backwards, it is now moving at an angle? So initially, let's say this lady on a pram, she was moving at a velocity of 5 in one direction, but now she starts climbing up a hill. Her velocity cannot be explained very simply. So now things have got complicated. So now her velocity will be explained as 3 plus 4i. The angle at which she is moving will be taken by taking the tan inverse of 4 divided by 3. I think it will be an angle of around 53, 59, I don't remember. The magnitude of the velocity is still 5, the total magnitude, because for that you will have to take the square root of 3 square plus 4 square. It will come back to 5. But 3 plus 4i means that now it is moving at an angle. What angle? Do tan inverse of 4 divided by 3. The net magnitude is still 5, but now there is a horizontal component and there is a vertical component. The horizontal component, or the component that is parallel to the ground, is the real part. It is denoted by 3. The perpendicular component, which is the component perpendicular to the ground, is denoted by 4i. It is called as the imaginary part. Another example denoting complex numbers. First of all, in the previous case you saw how one force, one impulse, velocity got divided into two parts. 5 got divided into 3 plus 4i. Now let's look at this image that you see here. The cylindrical like object has as if got two components when light is shed at it from different angles. From one angle it looks like a rectangle, from another angle it looks like a circle. One part we call as the real part, one part we can call as the imaginary part. Usually the real part is the part which is parallel to a certain reference surface, and the imaginary part will be that component which is perpendicular to whatever the reference surface is. The reference surface or the reference plane will be ground. It can be something else. It varies from different. It can be a wall surface. Who knows? It will vary from cases to cases, and it is usually used as a convention. But a rule of thumb is that that component which is parallel to the reference surface is called as the real part, and that component which is perpendicular will be called as the imaginary part. Let's come back to this image of complex conjugates. The same woman with a pram, when she moves at 5, she initially moves with the velocity of 5, then she climbs a hill. Her speed is denoted by 3 plus 4i, but now she goes on the downward slope of the hill. Now her speed will be denoted as 3 minus 4i. So I hope you understand the concept of complex conjugates. They are vertically opposite mirror images of each other. That is what they are. And now we can go into understanding this a bit more in detail. If you see this rotating arrow, this is 5, this is an angle of 3 plus 4i. This angle can be found out by taking the tan inverse of 4 divided by 3. 5i denotes a rotation by 90 degree. 5 is the magnitude. I means that a rotation of 90 degrees has taken place. Even in this case, minus 3 plus 4i, magnitude is still 5. What is the angle? You can find out by taking tan inverse of 4 divided by minus 3. Minus 5 means the magnitude is still 5, that is the length of the arrow hasn't changed, but now the direction is opposite, it has rotated by 180 degree. Minus 3 minus 4i again means that the length of the arrow has not changed, because if you take the magnitude square root of 3 square plus 4 square, it is still 5, but there is a certain angle that has taken place. This angle can be found out by taking tan inverse of minus 4 divided by minus 3. Minus 5i means the magnitude is still 5, it has not changed, that is the length of the arrow has not changed, but now a rotation of 270 degrees has been taken place in the anti-clockwise direction, or a rotation on in the other direction has taken place, 90 degree in the clockwise direction. There are two ways to reach this point. One is by a rotation of 270 degrees in the anti-clockwise direction as this arrow is moving, as this arrow is rotating, or there's another way to reach this by rotating by 90 degree in the clockwise direction. And I hope this image is cleared out. Now we can move to the next image. Logarithms. What if someone told you that log gives you the cause for every effect? Whenever you plot a graph, you're actually plotting the cause onto the x-axis usually, and the effect onto the y-axis, and the base of the log, like log to the base 10 or log to the base e, is nothing but the rate at which this change is taking place. So let us take an example. Let's say you have kept water to boil. You plot the temperature increase on the y-axis and you plot the time taken on the x-axis. The rate of change is the slope of the graph, and this is the base of the log. So if you take log to the base of the rate at which the temperature is increasing of the temperature, you get the time taken to reach that temperature. So let's say temperature increases by 10 degrees per minute. So it will be log to the base 10, and let's say the temperature right now is 70 degrees. So how much time it took to reach the temperature of 70 degrees? That is what log gives you. So log to the base of rate of effect gives you the cause. This is another way to look at it. It is given in the image below. Log to the base of slope of graph. Slope of graph is also denoted by dy upon dx of the y coordinate. Y coordinate is whatever you plot on the y axis. It is usually the effect. Gives you the x coordinate, the corresponding x coordinate. That is whatever you plot on the x axis. Usually it is time, but not necessarily always time. Here is another example. Let's say you have plotted time on the x axis, distance covered by a car on the y axis. The velocity of the car will be the base of the log. So log to the base of velocity of distance will give you the time taken to reach that distance. Now we come to integration or calculus, as some people call it. You might have come across whenever integration is done, at times it is integration with respect to dx, at times it is integration with respect to dy, at times it's integration with respect to dr. So what do they all mean? Dx means just keep adding along the x-axis. Let's see, this is the x-axis. As you see, the direction in which the bricks are added. the y-axis will be dy, it will be perpendicular to the x-axis. Dx means keep adding along the x-axis, dy means keep adding along the y-axis, dr means keep adding along increasing radius, dh means keep adding along the height, d theta is a bit different, it means keep adding or keep rotating along a vertically curved path, and d psi it simply means that keep adding along a horizontal curved path in a horizontal plane. So d theta is rotation or addition that takes place in a vertically oriented plane, and d psi is rotation in a horizontal plane. So here is another animated image which denotes rotation in 1D, 2D, integration in 1D, 2D and 3D. Integration in one dimension, it is called as single integration. You might have come across it. Integration with respect to dx or integration with respect to dy. If you are adding bricks along the x-axis or only along the y-axis in only one direction, in only one dimension, single integration comes into the picture. If you are adding bricks along the x-axis and along the height, that is, you are moving in two directions, now double integration will come into the picture. So this is 2D. And triple integration is synonymous to 3D. If you're adding bricks in all the three dimensions, along the x-axis, along the y-axis and along the height, now it is triple integration. It's not necessary that it is always a spatial dimension in which things are added. It can be that the third dimension is time. For example, integration with respect to x, with respect to y and with respect to time, that is, with time, how much does the image grow, how much does your work or the structure that you're building grow. It is not necessary. Albert Einstein in his equations showed that showed time as the fourth dimension. So that is one example of integration. Now let's compare integration with derivatives or differentiation. This is one way to look at integration and differentiation. This image is there inside the book. Integration is simply adding. You take a single disk and keep on adding it along the height. What you get is a cylinder kind of a structure, and even the volumes, the area of the disk, when you keep on adding, now you get a volume. This volume is the volume of a cylinder. So the area of a disk is pi r square. The volume of a cylinder, when you keep adding it, integrating it with respect to dh, now you get pi r square into h. This is nothing but the volume of a cylinder. Differentiation or derivatives is the reverse process of that. If you keep on removing disks from the stack of cylinder that is formed due to the disks, what do you get? What is the residue, the derivative? It will be a single disk. So derivative is finding the building blocks, breaking it into components. Integration is building bigger structures out of components. Derivatives is breaking things to the building blocks. So d by dh of pi r square h will be pi r square. So d by dh of a cylinder will be a disk. Another example can be a cylinder. Any cylindrical structure can be cut into disks like cutting a cucumber. So integration and differentiation are the reverse processes of each other. Now let's come to divergence. Whenever you have a certain field, there will be a source of that field. It can be the source of heat, it can be the source of light, it can be the source of sound. Now whenever you move away from the source, there will be a rate at which you will find that the magnitude, the amplitude of that force will keep on reducing. This rate at which the intensity, the amplitude of that field reduces is called as divergence. This divergence, this rate of change takes place along the x-axis, along the y-axis and the z-axis. It's not necessary that when you're moving away from the source, you move in only one direction. For example, you can take a path away from the fire such that it includes the x-axis, it includes change in the x-axis, it includes change in the y component, the y coordinate, and along the z component. Let's say a fire is burning on one side of the room, in one corner of the room, and you move diagonally to the opposite corner of the room. Now you have covered the x and the y axis, and not just are you moving diagonally opposite onto the other side of the room, you're even standing upon a stool. So now the z component is also changed, the z coordinate is also changed. So the rate at which now the heat changes as you move away from this fire, that can be calculated. That is called as divergence. It is the rate of change that takes place along the x-axis, along the y-axis, and along the z-axis. And double divergence will be the rate of change of rate of change. It's not necessary that the rate of change is constant, just as it's not necessary that the velocity will be constant. There can be a rate of change of velocity also, that is called as acceleration. Similarly, double divergence will be the rate of change of heat, so on. Now let's go to the next image of curl. Curl is the ability of a field or a force or an influence to make you spin. As you can see in the formula of curl, you will see I, J and K. I denotes a rotation in this plane, that is the plane of the screen, a rotation along the plane of the screen. J denotes a rotation in the horizontal plane. It can be a to or fro rotation. If it anti-clockwise rotation is denoted by positive, clockwise rotation by negative. So J would be the plane of the table on which your laptop or the ground is kept. So anything that rotates in the J direction in a horizontal plane is denoted by J. K denotes a rotation in a plane that is coming towards you or away from you. Imagine a car moving towards you. The wheels of the car are now moving in a K dimension, a K plane with respect to you. That is, they are moving in front of you, or they may be moving away from you if the car is coming towards you or away from you. So these are the three different planes of rotation. So whenever you look at the formula of curl, I, J and K denote rotations that might be happening in all these three directions. Is it necessary that rotation is taking place in only one direction? No. It may be happening that a certain rotation, a satellite which may be moving around the earth, may not be moving necessarily in only one direction. It may be taking a very inclined path. For example, the rings of Saturn are nothing but meteoroids or rock particles revolving around Saturn. They moved at a certain tilt, so they are moving along the I and somewhat along the J and maybe somewhat along the K direction. Now let's look at del upon del x. This is the rate of change along the x-axis, the rate at which you are rotating along the x-axis. So it's called as dava. I think dava upon dava y is the rate of change of rotation with respect to the y-axis, and dava upon dava z is the rotation taking place along the z-axis. Whenever you're rotating, your position is changing along all these three axes. The rate at which this position keeps changing is denoted by these formulas. Fx, Fy and Fz are the forces along these, the forces which are pushing you along these lines and so on. Then let us look at matrices. The next image is on matrices. The diagonal of the matrix, as you know, is like the axle of a wheel. It is the axle around which rotation takes place, and that is why the diagonal elements stay where they are even after the entire transpose of a matrix is taken. You might have noticed that the diagonal elements don't change. This is very similar to the rotation of a wheel. Everything goes up and down, but the center of the wheel remains where it is. Buddhist and Zen monks explain this as remaining centered. They say your life will be full of ups and downs, but you need to be centered at a certain point in your life. If you stay in the mind, your life will go up and down, so stay at a certain position. Stay centered in your soul, they say. Stay centered in your consciousness. Then you won't feel it. Things will go up and down, but you will stay stable. You will stay centered. You will stay poised. And you can see it in the rotation of a wheel or in the rotation of a fan. The central elements stay where they are. They don't exhibit a lot of change. The axle of the wheel, they stay where they are. They don't exhibit. Even when the whole, in this image that is shown to you, everything moves from up to down. They get translocated from one place to another. This image shows the rotation of a matrix by 180 degree. The rotation of a matrix by 180 degree around the diagonal is also called as the transpose of a matrix. And you might have seen how things change whenever you take the transpose of a matrix, right? Now, what happens when you take the transpose of a matrix is everything changes. Things change its position, but the diagonal elements remain where they are. And the transpose of a matrix is a rotation by 360 degrees. Transpose of a matrix is rotation by 180 degrees around the diagonal once. And transpose of a matrix is rotation of the matrix by 180 degrees twice. So a total rotation of 360 degrees. So that is why the transpose of a matrix gives you the same matrix. What if everything I tell you that you watched all in this video is can be visualized at just one spot? What if I tell you that it's called as visualizing math numbers? It's the first part. There's the second part also. Rotation by 90 covers degrees. All these chapters from trigonometry to vectors to complex numbers, rotation, logarithms by 180 degrees. I raised to 3 or I cubed denotes a rotation by 270 degrees. And I raised to 4 would be a rotation by 360 degrees. In the description. So not just I raised to 4, I raised to 8, the price I raised to 12, I raised to 16, I raised to any multiple of 4 will be multiples as you know rotations of 360 degrees. So they will all be equal to 1. Say that they love math. What if I tell you actually that sine theta in trigonometry had a reason to exist, a language? Sine theta is a measure of how much perpendicular two forces are like a finger when they act upon each other. It's like the word He-Man kind of a person, or the word pineapple. Image. When he throws the ball onto a wall at 90 degrees, the full impact happens onto the wall. So when I speak of apples, so sine 90 I don't have 1 upon an apple onto the screen, or it is loosely written as 1 when we write it, but it is actually a ratio. I just have to say 1 upon 1. This ratio 1 upon 1 denotes full upon full, just as 1 upon 2 denotes half of full, the word pineapple 1 upon 3 denotes 1/3 of full, 1 upon 1 denotes full upon full. Object. It's nothing but so a sine 90 equals to 1 because maximum force transfer happens at 90 degree from the ball onto the wall. If the same person throws the ball onto a wall at 30 degrees, either love the physics of it, now only half of the impact takes place. Physical phenomenon, but math is just a language 30 equals to understand that because now only a fraction of that force gets transferred onto the wall. This fraction is half at 30 degrees. Hence, sine 30 is 1 by 2. Do not. What if I tell you that cos, as you can see in the image at the right topmost does not have a meaning on the screen. Complex numbers, imaginary numbers. Cos is a measure of how much aligned two forces are, aligned figment of your imagination. When the sphere is kept parallel to the surface of the ground, the maximum shadow you are searching for answers falls upon the ground. Convinced by the answers that the world gave you, two forces are aligned, and when they produce maximum and do not settle cos comes into the picture. That is why cos 0 searching have the humility to say because 0 degree is the angle. These when two most difficult words are parallel, are acting parallel, or are completely in alignment. To have the humility to say I don't know. Now, and a lot of problems take place because people in the world at an angle of 60 degrees don't have the humility to say I don't know. People who don't have this humility don't search, they don't inquire. The length of the shadow gets they become lazy to inquire, and a mind which is lazy to inquire is quick to conclude. Now is quick to form opinions. The spear and the surface of the table that this is the way completely out of alignment. They are at 90 degrees meaning each other. So, and they end up becoming calculation monkeys. That is subtended, that is formed by the United States. Now the minimum. The calculation monkey is someone who whenever two forces are such that they produce the maximum satisfaction when they are without understanding minimum impact, the actual meaning at 90 degrees of whatever is going on comes into the picture. And it is necessary to understand what is going on. What is this resource? If it's there in equations, it's there in your life. Conjugates are nothing but equations, it is happening somewhere in the universe of each other. Always remember that 3 plus 4i denotes a certain there's a saying which that I written can be calculated by taking tan inverse of 4 divided by 3. If you can't explain something to someone, simply confuse him. And 3 minus that is a strategy that a vertically many of the times mirror image at you. That's it. And you got confused. Also told you that might have developed an inferiority complex by now that rotated. You're not understanding math 180 degrees. Something is wrong with you. When this rotation takes place, there should be an axis of rotation. This axis the fact is the reverse was true. They don't have the humility to understand, as you see here. And the diagonal of the matrix is because of the humility to say these 3 words. It's the axle around which the entire matrix rotates. So the link of the book is given in the description. The ebook is available for $6. And the transpose so thank you for your time, thank you for your attention, and I'll meet you in the next video. Thank you so much. Sorry for the voice quality. The diagonal. I can't help it. I don't have a microphone. I'm working on all the contents of this book